Now, in the next part of our seminar, we're going to look at some shortcuts we can use to show triangles are congruent. That is, you don't have to show me 6 parts all the time. We have some ways of showing triangles are congruent, and we have other ways they don't have to be congruent. They might be, but we can't use deductive reasoning on it because they don't have to be congruent. The first one is side, side, side. If you have a triangle with 3 given sides, there's only one triangle you can mark that way. So any other triangle, like if I have a triangle that has sides of 2, 3, and 4, if I draw another triangle with sides 2 and 3 and 4, I can only do a reflection, a translation, or rotation of that triangle. I can't make a different triangle, so they have to be congruent. If I have 2 sides and the included angle, what I mean by that, let me erase this and show you. Let's say I've got a triangle here. If I have 2 sides marked congruent, and I know the angle between those 2 sides, there's only one way to draw that triangle. It's going to be unique. So side angle side is one way to draw the triangle. Now, what isn't true is side side angle. And that's kind of hard to explain to see, but here's what happens. If I have an angle and 2 sides, I might have another triangle over here that's obtuse that still has the angle and the 2 sides congruent. If you read that backwards, angle side side, that's a bad word. We're not going to write that down on a paper anyplace. So that's another way you can remember. No bad words in geometry. So don't use side side angle as a reason to show triangles are congruent. Then we have angle side. That is unique. That actually angle side angle is unique also. That is, if I have 2 angles, sorry about that, it keeps on jumping on me. If I have 2 angles and the side between them, then that must be true. An angle side means I have 2 angles and then non-included side. Now, it's got to be in the same corresponding part, otherwise it's not going to work. Those are the big 4. We have a 5th one, which we call HL. And HL says if you have a right triangle and you know the hypotenuse and you know a leg, then if you draw another right triangle with that corresponding hypotenuse and leg, then you can use that. Notice that that's actually a special case of side-side angle. But the special case is because of the size of the angle that makes it work, since it's a right angle. You can't use HL unless you have a right triangle. The other one that people sometimes try to use is angle, angle, angle. Those don't have to be congruent. I'm going to erase the triangles here and draw 2 triangles that have the same angles but aren't congruent, if I can draw very nicely at all. So I'm going to try to draw an equilateral triangle here. So we know all 3 angles are the same. They're all 60 degrees. Well, inside this one, I'm going to draw another equilateral triangle. You can definitely see they're not the same, are they? They're going to have the same angles. They're going to look alike, but they're not going to be the same size. One's a dilation of the other. Now let's do a couple problems to show you how you apply this to do your proofs. So when we do our proof, and you can use 2-column, paragraph proof, flowchart proof, however you want, always start with your given, and then write down what you know because of the given. And if you use side, 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 make sure sorry about that, it's just not cooperating. Make sure that you have side, side, side in your proof. So statement, reason. I have 2 givens going on here, and also do the do it on the picture. Prove to yourself that it works, and then do the writing. So we're going to start. L is the midpoint of segment WE. And WR is parallel to ED. We know that because it's given to us. Now, let's take a look. L is the midpoint of WE. What does that mean? Well, that means L is smack dab in the middle of segment WE. So in other words, WL is congruent to LE. My W looks kind of sick there. I'm going to rewrite the W. And why do we know that? Well, because we had this vocabulary word. The vocabulary word is the midpoint. So it's the definition of midpoint. So whenever you have a vocabulary word given to you in the proof, usually, not always, but usually you're going to have the definition of that vocabulary word in your proof at some time. Now let's look at our other given. Other given is not congruent. Our other given says WR is parallel to ED. We have to go back to what we did in the previous unit. If you have parallel lines, we know we have some angles that are be congruent if they're cut by a transversal. So in this case, angle R and angle D, they're alternate interior angles. And at the same time, I could say angle W and angle E are congruent. So let's write that down. So we're going to say angle W is congruent to angle E, and angle R is congruent to angle D. I'm going to put both those on the same line for the same statement because they both have the same reason. Notice they are alternate interior angles. So we know if we have two parallel lines, then the alternate interior angles are congruent. Now, notice what we have in each diagram. I've got two angles in the non-included side. And notice, like in this case, the light purple is across from my tick mark. The light purple is across from my tick mark. So I've got two angles in the non-included side. So my reason is angle, angle, side. If the side was between them, I'd say angle, side, angle. That's the only thing I would do different on this one. And now what we're going to do is we're going to write down the names of our triangles. So we're going to say triangle WRL. You really can't get it wrong, how you name the first one. And just make sure the other one matches up. Angle W is my dark purple one. So I'm going to start with triangle E. Then angle R is my light purple, so that'll be D. And angle L is my vertical angle. Notice I could have used vertical angles here, but I chose not to. Now that you've got these triangles congruent, they might ask you something else. Let's say I'm going to add on to this. We're done with this proof, but now I've got a different problem. Let's say it's all set up. Only this time, instead of proving the triangles are congruent, I want you to prove that WR is congruent to ED. Well, guess what? We do the proof the same exact way. The only thing is, once we get down here to where the triangles are congruent, notice WR is my first two letters, ED is my first two letters. So I'm just going to add one more statement on here. I'm going to say, oh, segment WR is congruent to segment ED. And you could say definition of congruent triangles, because that's what it would be. But you're going to notice we like to use CPTCC because it's shorter. It's actually not shorter, but the abbreviation is shorter. What the heck does that stand for? It's a good question. Corresponding parts of congruent triangles are congruent. There you have it. Corresponding parts of congruent triangles are congruent. That's CPCTC. You could also use definition of congruent triangles if you so choose. When you do your assignments on Alex, the pull-down menu is going to have CPCTC in it, so that's why we're going to use that one. Okay.